Alright, hello Science 10, Mr. Beeland here with your lesson for today. We are still talking about energy, and we're going to be focusing on mechanical energy here. And in particular, mechanical energy can be split up into two other types of energy. One of them is kinetic, and the other is potential. Okay, so anytime you have any sort of mechanical energy, it can be broken up into these two things, and we can always remember that kinetic plus potential equals total mechanical energy. Okay, just keep that in mind. So with kinetic, okay, this is the energy of motion. Okay, so again, all objects have kinetic energy, have at least some. All objects have, and they use Ke for kinetic energy. And the faster the object, no surprise, more kinetic energy. Okay? In specifically, it is that the kinetic energy exponentially increases as you increase velocity or speed. Okay, so again, it is not a one-to-one ratio. The faster you go, the kinetic energy builds up more and more. The other thing that can affect your amount of kinetic energy is how heavy the object is. So the heavier the object, the more energy is needed or is in the object. Okay, and in particular, it is linearly increased. So that means that, again, an exponential means that it increases faster, whereas linear, as you increase mass, there is a bit of a ratio, and it just goes up by that much. So the whole equation for kinetic energy actually ends up being Ke equals 1/2 times mass times velocity squared. Okay, so kinetic energy equals 1/2 times mass times velocity. So as you increase mass, kinetic energy is going to go up, but it's going to go up fairly consistently. Whereas if you increase velocity, it's going to spike up, like you can see here. Okay, so then we have potential energy, right? And we're just going to use PE for that one. Okay, and potential energy depends on the location / position of the object. Okay, the reason why we call it potential is because the object has the potential to do some work. Okay, so what does this look like, or how does this work? We can further break down potential energy into two other types. You've got gravitational, and we've got elastic. Okay, and so gravitational object is energy that's stored due to the height of the object. Okay, so the higher you hold an object, the more it will, the further it will drop, the faster it will go, right? And so this gravitational potential energy is, it exists because of the Earth's gravity. Okay, so it exists because of the Earth's gravity. If the object is lifted up and then it gets released, it accelerates down to the surface, right? So the higher the object, the more potential, the further you've got to go, right? So the more potential energy you've got. As well as the heavier the object, your potential energy also goes up, right? Because again, you have the potential to move more mass in a certain direction, right? And these two things are linear. Okay, this is a linear relationship, which again means that it increases proportionately 1-to-1. So what ends up happening here is that potential energy for gravity, put a little g there, potential energy for gravity equals mass times height times gravity. Okay, gravity has a specific number. We'll talk about that one a little bit more later in another video, but that it is all linear. If you increase mass by a little bit, it does have a proportional increase in potential energy, right? So it's a little different than the velocity from before. Okay, there is one other one here we're talking about, and that is elastic. Okay, so this is energy that is stored in stretched or compressed material. So we're talking about in rubber bands or in springs, things like that, right? It wants to go back to its natural or neutral state, and the more you stretch or compress, then the more potential energy you'll have. That equation is a little bit more involved. We're not going to worry about that one in this year, but just know that as you stretch or compress a elastic or a spring past where it wants to be, there will be more potential energy stored as it tries to go back to that natural position. Okay, so again, to summarize, mechanical energy is broken down into two pieces: kinetic and potential. Those two things together give you your total energy. Kinetic is motion. Okay, so the faster the object goes, the more kinetic energy you're going to have. And the heavier the object is, then the more energy there is there too. The only difference is that as you increase mass, it is going to go up by a little bit consistently every single time. It's linear, so it just goes up a step, up a step. But with velocity or your speed, it is going to start going really fast. You're going to get lots of energy really quickly. Potential energy is, again, it is the potential. It is there. It could perform the work. I've got this pen up off the table. It could start moving. It could drop if I let it go. So it's got the potential to do something. The higher the object, the more time it has to accelerate, so the faster it's going to end up being as it comes down to the table. So the higher it goes, the more potential energy you're going to have. And again, there is a difference between me holding up a pen versus me holding up a boulder, right? It's going to have more energy if I'm holding up the boulder. These potential energies can be broken into two types. Again, we've got gravitational, and then we've got elastic. Gravitational is really the one that we're going to be dealing with a lot, and that is a linear relationship between mass and height, and it gets times by a constant that we just call gravity. Because again, the gravity on different planets is going to affect how much energy there is potentially there, right? If you drop something from this height here on Earth, it's going to have a lot more energy than if I did it on the moon, right? On the moon, it would just kind of float on down, right? So there is a difference there. And then again with elastic, it's just whether or not you're stretching or compressing something, and then it wants to kind of bounce back to where it's supposed to be, right? Okay, that is it for today's lesson. Take care.